So students, today we have to start with the average cost. Yesterday I have explained you regarding the schedule of the average cost, how average cost, that is your average fixed cost, average variable cost and average total cost, it behaved in the short run. Alright, with the help of schedule we have already discussed. Now we have to discuss with the help of the diagrammatic explanation, with the help of diagrams, that what is the behavior of average costs in the short run. Alright, you all must recall the schedule that we have discussed yesterday. Alright, what was the behavior of average fixed cost, then what was the behavior of average variable cost, and what was the behavior of average cost. If you recall the schedule, in this schedule we were able to see that the average cost was continuously falling. It was continuously falling. And what was the behavior of average variable cost? It was falling at the initial stages. It reaches at the minimum point and it again started increasing. And same was with the case of the average total cost. So with the same behavior, by seeing the same behavior, we can draw the three curves, that is average fixed cost, average variable cost and average total cost or average cost. Alright, average cost. Now few of the formulas that you should remember before we start the class. Yesterday I have told you that average cost is nothing but the addition of average fixed cost plus average variable cost. Alright, this I have already told you. Now coming on to the diagrammatic explanation. First of all, we will draw the average fixed cost. Alright, we will draw all three: average fixed cost, average variable cost and your average total cost on the same diagram. Alright, in the same panel. Alright, so draw it simultaneously everyone, and after the class send me the picture of the diagram and it should be perfect like I have made. Alright, this is your origin, this is your y-axis. Alright, on the x-axis what we take? We will take output, and on the y-axis what we will take? We will take cost. Here, since we are measuring the average cost, then you can write that we are taking average fixed cost, average variable cost and average total cost on the y-axis. Now coming on to the behavior of average fixed cost. Just revisit the schedule. See the schedule. The average fixed cost was continuously falling. So we have to draw a curve which is continuously falling. So I will start from this point and I will show that the curve is continuously falling. This will be my average fixed cost. Alright, this will be my average fixed cost. I will explain that why these costs behave in such way. Alright, why is it so that average fixed cost is continuously falling? The first question arises why AFC falls continuously. Okay, why AFC falls continuously? So what is the answer to this question? We all know that what is AFC? AFC is nothing but total fixed cost divided by the output. Alright, and when you see the schedule, we all know that total fixed cost remains constant. Total fixed cost is always constant irrespective of the output level. That means in our example it will remain 120 only. and at the different levels of output, whether the output is 1, whether the output is 2, whether the output is 3, whether the output is 4, whether its output is 5, alright, or whether the output is 6. The total fixed cost will remain same. Okay. And if we have to calculate average fixed cost, then we have to divide the total fixed cost with the level of output. So if we divide the total fixed cost with the given level of output, what answers we were getting? If we are calculating AFC, we were at the first level of output, it was, my AFC was 122, then it was 60, then it was 40, then it was 30, then it was 24, and then it was 20. You can see in the schedule in the book that your average fixed cost was continuously falling. You can see the reason from this division. Alright, there is a pure mathematical reason behind the falling of the average fixed cost, behind the continuously falling of the average fixed cost. See what is happening here. This is my numerator, we all know, and this is my denominator. My numerator is a constant number, it is 120 everywhere, but my denominator is increasing. Alright, my numerator is constant and my denominator is increasing, that is 1, 2, 3, 4, 5, 6. Then mathematically what will happen? Of course the value will fall. Whenever we divide 120 by 1, we will get the higher value. If we divide it by 2, we'll get more less value. If we divide it by 3, we'll get more less value. If we divide it by 4, we will get more less value. If we divide it by 5, we will get more less value. And if we divide by 6, we get more less value. So since our numerator is a constant number and our denominator is continuously increasing, that is why average fixed cost is continuously falling. So what is the reason? What is the reason? The numerator, what is the numerator? That is the total fixed cost is constant and our denominator, what is the denominator? That is the output is increasing. Then naturally the average fixed cost will fall because my numerator is constant and my denominator is increasing. Alright, if I say that I have 100 chocolates, and if I have to divide those 100 chocolates with one person, then I'll give 100 chocolates to that person. Then if I have to divide that 100 chocolates with 2 persons, then I have to give 50 chocolates. Then again, if I have to divide it with 4 people, then I have to give 25 chocolates. Because the chocolates are constant, the number of people are increasing. That is why the average is falling. Same reason is here. Since the numerator, which is the total fixed cost, it is constant, and our denominator, which is the output, it is continuously increasing. That is why the average fixed cost is continuously falling. Alright, this was the first question regarding the average fixed cost, which has been asked many times in your exams. Now coming on to the other thing, you can see that although average fixed cost is falling, it is falling from y-axis to the x-axis, from left to right, it is continuously falling, but it is not touching either of the axes. It is neither touching the y-axis nor it is touching the x-axis. So why it is so that the average fixed cost is continuously falling, but it will never become zero? Okay, as soon as the average fixed cost touches the either of the axes, whether it touches the y-axis or x-axis, it will become zero, because I have already told you that any of the curve, if it passes through any of the axis, it becomes zero. So the second question is that why AFC will always remain positive. why it will never get 0? The answer to this question is also a mathematical thing. As we all know that what is our AFC? AFC is nothing but the division of TFC and output. Even if the output is 0, at the 0 level of output, the TFC will be some positive number in the short run. I have told you that in the short run, the TFC cannot be 0, because even at the 0 level of output, the producer will not throw away the fixed factors. So even at the 0 level of output, my TFC will remain positive. That is why the average fixed cost will also remain positive, because TFC will never get 0. Okay, so the reason to this answer that why AFC curve never touches either of the axes, the answer to this question is that TFC, that is total fixed cost, is always positive even at 0 output level. So since our numerator will be always positive, thus the value of AFC can never be 0. So these were the two questions that are basically asked regarding your behavior of AFC. And now we have to discuss what is the shape of AFC. The shape of AFC is a rectangular hyperbola. The shape of AFC are rectangular hyperbola. Alright, and we have already discussed that the shape of the unitary elastic demand curve, it was also a rectangular hyperbola. What is a rectangular hyperbola? It means that if we'll take any point on the AFC curve, we'll get the same value. Alright, we'll get the same value, because if we divide AFC by output, okay, we all know that AFC is nothing but TFC by 0. So whenever we divide average fixed cost by the output, we will get a constant TFC in the short run, because TFC remains constant. That is why the shape of the average fixed cost is a rectangular hyperbola, because at any point if we measure, okay, we will get a constant number, and that constant number will be the TFC, which remains constant in the short run. So such type of curve is also known as asymptotic. Okay, it is also known as that AFC is asymptotic to the axis. Asymptotic to the axis. Asymptotic to the axis means that it is not touching either of the axes. It will not even touch the y-axis. It will not even touch the x-axis. That is why it is said that your average fixed cost curve is asymptotic to the axis.